So we're here to solve a Slitherlink I wrote called Diagonals. It uses a lot of diagonal pattern logic that if you hadn't known before starting this puzzle, you'll definitely learn in part by doing it. As one example, a 0 of a 1, the 1 is never going to take these edges, but that now means where we've got one edge that's going to come into this vertex on the upper right, so either this top one or this right one. The other edge is going to have to come out from that vertex, and so for instance, we'll close off this one. This 0, 1 pattern means that we've got an edge coming into this 3, and so we're going to have to take the diagonal opposite edges, both of these two, and that actually completes out this 2 pattern. Another way diagonal clues work is 3s near to 3s will always have opposite borders used. That actually now forces this 2 pattern quite quickly. This 3 and this 3 actually have a chain of 2s across them, and so it turns out there's actually also the requirement that these diagonal stretches have to work for them. And in this case, because we already had some other information around these 3s, we can complete some of what those require. We get this pattern for this 2, get another pattern for this diagonal 2. This 1 can't come and take these edges, so it takes this edge. It's going to leave one of these unused, which leaves one of these unused, which means this vertex, which is joined in, will always come out. And do this. That completes the 0, 2, which comes over like so. And we're going to have to get out of this corner for this to be a valid pattern. This 0 next to 2, again, has a diagonal connection here, but it's coming into a 3, so it's got to leave enough space for that 3 to work. This will always have an end coming out, which now completes like so. We get these ends being drawn to just complete the grid. At the start of the puzzle, we could have looked at this corner 1 and known that we can't come into these top spaces. And because of how this side is actually isolated, we also can't come in to anything but this rightmost edge. But we also have a 0, 2, 3 pattern, as we said before, where this 2 is diagonal. We're going to have a 3 come in that's going to take the lower left edges, come up like this. That puts in this pattern. This edge comes in, this comes in, come across. This loop section doesn't want to close on itself. This whole loop section doesn't want to close on itself. So we get to this in the grid. Coming back to this full diagonal now, we've got 0s next to 1s, which use a pattern we've looked at before. In this case, for instance, we've got a 3 coming in here. Now this 1 will always take an edge into the 2, and that actually means there'll always be an edge coming out of the opposite diagonal. There's a communication through diagonals of 2s. So we can put this pattern in. In this lower right corner, we also have a similar kind of constraint. This 2 is going to be a diagonal connection around this cell, and that means we'll always take one of these 2 edges, but we can't take the right edge here because it would come into the 0, so we take this instead. We got one loop end coming out here, and we actually have now isolated most of this 3, which has just one option for it. That comes across, this comes across. So we got some part of the pattern of this loop forming here. We note that we've got 1, 2, 3 ends, and then this 3 having 2 more ends, and so there are some ways if this connects that we'd cause real issue. In particular, if this comes up, we're left with 3 ends in this space. So this has to come across instead and give these ends. These still need to dodge each other so that they don't close too soon. And so what we see is we get these ends coming up and the last edge of the grid to finish the loop. So a lot of uses of diagonal clue connections, and if you were familiar with some of those patterns, this would be a pretty easy Tuesday level puzzle. If not, there's definitely a lot of look ahead and things to learn about these pattern shapes, but the ways that you get connections through 1s touching 1s or 1s touching 2s or 2s touching 2s, etc. on diagonals is a key part of solving Slitherlink puzzles. So hopefully you got something from watching the solve, and we'll see you again soon.